Okay, let's take a look at performing a hypothesis test about a population mean via the z-distribution, the standard normal distribution, using the p-value approach. Now, these are our steps. Let me scroll up here. So I'm going to be referring back to those. Now, first off, note our first step is write down a shortened version of the claim. We're going to do that as we're actually working the problem. Okay, so here's our problem. Excuse me. And mean amount. There we go. The mean amount of fluid in a bottle of lens cleaner is 59 milliliters. Our researcher believes that the mean is actually lower than that. So that sounds like our claim. Lower than, less than 59. So mean is less than 59. 15 bottles are sampled. That's N. It's our sample size. Mean is found to be 58 milliliters. Since that mean is referring to the 15 bottles, it's sample mean. So that's X bar. With a population standard deviation of 1.2, that's sigma. Test a claim based on this information that alpha is equal to 0.05. Okay, and I forgot to get the standard normal distributions. Let me pause the video just for a second. Okay, I downloaded the standard normal distribution table, so we can continue on. Okay, so I got all this information here. Step 1, write down a shortened version of the claim. We already did that. It's important to identify your symbol. That's a less than. Step 2, write down a null and alternate hypothesis. H naught always has equals part on it. So I got H naught and H1. Since we're talking about the mean, these are mu. And I put the less than here. The only symbols you can put on H1 are less than, greater than, and not equal to. And the only symbol you can put on H naught is equals. Step 3, identify if the claim matches H naught or H1. Less than, the claim matches H1. Step 4, identify the following X bar sample mean. We already did that. Sigma, that's our population standard deviation, which we did here. N, which is our sample size, which I did here. Mu naught, which is the number used in step 2. So mu naught is going to equal to 59. It'll be the same number you use on both these. Actually, should be the same number you have in the claim. Step 5, find the test statistic using the following formula. So Z is equal to X bar minus mu naught over sigma divided by square root of n. Okay, X bar is 58 minus mu naught, which is 59, divided by sigma, which is 1.2, divided by square root of n, so square root of 15. And I don't have my calculator up and running, so let me get that up. Okay, so I'll put parentheses on top, 58 minus 59, close parentheses, divided by, put parentheses on the bottom, 1.2 divided by square root of 15. 15? Yeah, I guess it is 15. Don't need closing parentheses at the very end for this calculator, so we get this. It's best to take it to 2 decimal places if you're using tables, because that's what tables are based upon. Negative 3.23. Okay. Then we're going to find a p-value using one of the following types based on the symbol from the alternate hypothesis. From our alternate hypothesis, we have a less than on it. So if I come down here and look, first case is greater than, second case is less than, third case is not equal. So we're going to look at case 2. So this is case 2. And that says, look at the test statistic from step 5 in the standard normal distribution table. Okay, so we're looking at negative 3.2. We separate the first part of the number, the integer part here, and then the first decimal place, and then the last part, which would be the hundredths place, this 3 right here. So we'll look at the intersection of negative 3.2 and 0.03. Negative 3.2 and 0.03. Right here, if you see where my cursor is circling, 0.0006. That's our p-value. Then step 7, compare that to alpha. Alpha is 5%. Obviously, p is less than alpha. So let's see what this says. If p-value is less than alpha, it says reject h0 and accept h1. So we're going to reject h0, and we're going to accept h1. Then it says determine a claim based on step 3. Well, up here we identified our claim matches h1, so whatever we say about h1 is what we say about our claim. We accepted h1, so it means we're going to accept our claim. Now, just to verify this, I'm going to plug this into my spreadsheet that I've created. And I know if you're watching this, you're probably more into the by hand part, but okay, number off the claim is 59. Alpha is 0.05. Population standard deviation is 1.2. Sample mean is 58. The N is 15. We have a less than. And where's less than? Right here. And I'm surprised that came up that close. Usually the by hand and the technology come off somewhat. But 0.0006. And that's how you get the p-value on that spreadsheet. Okay, so let's clear this off. And there we go. And let's take a look at the next one. Okay, the mean amount of fluid in the bottle of lens cleaner is 59 milliliters. Research believes the mean is different than that. That sounds like my claim. Different than, was it 59? 59. Now, different, by the way, the note means not equal. See, 35 bottles are sampled, so N is 35. Mean is found to be 63 milliliters. Since that's referring to my sample, that's my sample mean. So X bar is 63. With a population standard deviation, that's sigma, 2.3. Test a claim based on this information that alpha is equal to 0.01. Okay, so that's all our information. Step 1, write down a shortened version of the claim. We did that. Step 2, write down a null and alternate hypothesis. H0 always has the equals part on it. We're talking about the mean still, so that's my equals. And this is, let's try it again. This one's not equals. because that's what this symbol is here, and that's the only place we can put an H1. Remember, we can put less than, greater than, and not equal to on it. That's the only symbols we put on here. And that's B59, and that's B59. Step 3, identify if the claim matches H0 or H1. It's based upon your symbol, not equal, not equal. So our claim matches H1. Step 4, identify the following. X bar, which is our sample mean, which we identified. Sigma, which is our population standard deviation, which we identified. N, which is our sample size, which we identified. And mu naught, which is the number used in step 2. So mu naught would be what we put here, which would be 59. Step 5, find a test statistic, I'll learn to talk someday, using the following formula. Z is equal to X bar minus mu naught divided by sigma divided by square root of n. So X bar is 63 minus mu naught, which is 59. Sigma, which is 2.3, divided by square root of 35. And I'll put that in our calculator. So 63 minus 59, parentheses rounded, of course, divided by 2.3, divided by square root of 35. So second x squared and 35. And enter. And we got a very extreme value here, so this will be interesting. 10.29. Okay. So 10.29 is our test statistic. Find p-value using one of the following types based on a symbol from the alternate hypothesis. Symbol on our alternate hypothesis this time is a not equal. So that's case 3, not equal in H1. It says look up the test statistic from step 5 in the standard normal distribution table and label this value as A. We're not going to find it in our table, but this is how it's split it up. Take your integer part in the first decimal place, and then your hundredths place, which is the 9, and look up 0.09. Okay, if I come over here and look that up, the largest one is over here. So that's as good as it gets in terms of looking it up. 0.9998. And this says after we look that up, labeled as A. Then look up a test statistic from step 5 in standard normal distribution table, which we just did, and subtract it from 1 and label this as B. So B is going to be equal to 1 minus what we just found there, which I'm not very good with decimals, but I think that's, yeah, 0.0002. Then it says take the smaller of A and B and multiply by 2. Well, our smaller value is this one right here, so we're going to multiply it by 2. So p-value is equal to 2 times 0.002. And I'm pretty sure this won't match the spreadsheet at this point, just because we did vast approximation there. Okay. P-value is obviously, where's alpha? Okay, yeah. P-value is obviously less than alpha. So this says if p-value is less than alpha, reject H0 and accept H1. So reject H0 and accept H1. And determine the claim based on step 3. Since our claim matches H1, whatever we say about H1 is what we say about our claim. We accepted H1, so that means we're going to accept our claim. Okay. So, let me come over here. And we'll put in a spreadsheet, see how it compares. So 59, alpha was 0.01, population standard deviation, where's sigma? 2.3, sample mean was 63, n is 35, and it's rounding these, of course. But see the not equals, it says is 0. So that's the difference when you're using technology versus this. Now, is it really 0 or did it round it? Hard to say. But when you got that extreme of value, it's not surprising that it would be either 0 or 0.00000, so forth. Okay, so that's the not equal to case. And the last case. Let's take a look at this one. Okay. The mean amount of fluid in bottle lens cleaner is 59 milliliters. The research believes the mean is more than that. So more than 59. Uh, 25 bottles are sampled, so that's my N. N is 25. The mean is found to be 61 milliliters, so that's my X bar. With a population standard deviation 2.1. That's our sigma. Test the claim based on this information, and alpha is equal to 5%. And I guess that's all the information. Step 1, write down a shortened version of the claim. We did that. More than, of course, is greater than. You really need to identify your symbol. Step 2, write down a null and alternate hypothesis. We're talking about the mean, so these are both mu. And the only place you can put a greater than is on H1. And this always has an equals. So again, the only symbols you can put on H1 are less than, greater than, and not equal to. Step 3, identify the claim. If the claim matches H0 or H1, it's based upon your symbol, greater than. So claim matches H1. Step 4, identify the following. X bar, which is 61. Sigma, which is 2.1. N, which is 25. And then mu naught, which is a number used in step 2. So mu naught, and that's alpha. I don't make them very well. Mu naught will be 59. It's actually whatever numbers on any of these, they should be the same for your basic problems. Step 5, find test statistic. Z is equal to X bar minus mu naught divided by sigma divided by square root of n. So I got 61 minus mu naught, which is 59, over sigma, which is 2.1, divided by square root of n, so square root of 25. Okay, so I got 61 minus 59 divided by 2.1 divided by square root of 25. And press enter. And still an extreme value. That's... At least you see the steps. 4.76. Okay. Then find a p-value using one of the following types. This is a greater than on H1, so we're going to use case 1. We'll look up the test statistic from step 5 in the standard normal distribution table and subtract from 1. So we're going to look up 4.7 and in our hundredths place, which is 0.06. This doesn't exist in our table, but the closest we get is 0.9998. And then it says we're going to subtract that from 1. Okay, so again, subtract from 1. Then, conclusion, compare that to alpha. This is obviously less than alpha. P is less than alpha, so that says we're going to reject H0 and accept H1. So reject H0 and accept H1. Now our claim matches H1, so whatever we say about H1 is what we say about our claim. We accepted H1, so it means we'll accept our claim. Let's compare this to our spreadsheet. And 59 alpha was 0.05. Population standard deviation were sigma 2.1, 61, and n, which is 25. Greater than is right here. And again, our technology is more accurate than our table. This table is based upon rounding. And even then, we rounded 4.76 up here, and you can see from the test statistic here is much more than that. But this is scientific notation. That means you move your decimal point 7 places to the left. So your p-value would be 0.00000958871, which is less than alpha again. But that's how you come up with these right here. Now I've never have actually put this into words before, so I did that. So if you do find there's any issues with that, please let me know. This is version 1 of this. It's always been my idea to put that into steps, so that you wouldn't have to draw the picture and mentally think about what does that p-value mean in terms of the area and where you put it in the left tail, right tail, or both. But anyway, that's how to use the p-value approach to solve those type of problems.